In this question, they are asking us to solve an inequality containing absolute signs. So the best part is that both of them have one absolute part each. So the best thing is that we square both sides. And when we square both sides, they become positive, right? Positive of any number is positive. So we will write, you can write this as 2x minus 1 square is less than 3x plus 1 square. So I have converted absolute into brackets because it doesn't matter in square what was inside. So let's open the brackets now. 4x square plus 1 minus 4x. This is the left side when expanded. And when it is squared, it will be 9 x squared plus 1 plus 2x. This is what bracket it will become. So let's open the right side. 4x squared plus 1 minus 4x is less than 9x squared plus 9 plus 18x. Since 9x squared is more, so let's bring everything to the right side. So it becomes 0 is less than 9 minus 4, 5x squared, 18x plus 4x, 22x. And this will be 9 minus 1 plus 8. Alright, so let's swap the places, right? So we do better. 5x squared plus 22x plus 8 is greater than 0, right? Because this one is greater. So let me hurriedly factor this and I'll get the zeros. So I got zeros. This will give us x equal to minus 2 over 5. And this will give us x is minus 4. So now to find the exact answer, we will put number line with these two roots. Minus 4 is smaller, minus 2/5 will be bigger one. So let's take a number less than minus 4, which is say minus 5. Okay, minus 5. Put that into this inequality. So I'm doing it mentally, you can do it with calculator. So if I put it there, it becomes minus 25 plus 2 minus 23 and minus 5 plus 4 is minus 1. So it will be positive 23. So this gives us a positive answer. And we want greater than 0. Yes, we want positive. So this is one of the answers. Let's say a number between minus 4 and minus 2/5. Say minus 1. Right? So minus 1 if I put here, it becomes minus 5 plus 2 minus 3 and minus 1 plus 3. So it will give a negative number. So this is not our answer. So we'll make a number greater than minus 2/5. Let's take 0. So it will give us 2 times 4, 8. Positive. So Z. So final answer will be x is less than minus 4, x is greater than minus 2/5. In this question number 2, they are simply asking us to draw a diagram that represents these two inequalities. Okay, so let's focus on them one by one. The first one says z plus 1 minus I. Z is a random complex number. So we will change it to this format. Z minus Z1. Okay? And that Z1 will be the second part. So if I change 1 minus I, it will become minus 1 plus I inside this bracket. And this is our Z1. Okay? And this is that variable complex number which will be less than or equal to 1 with reference to Z1. So let's see where is Z1 first. Minus 1 plus I. Minus 1 will be somewhere here and plus I will be somewhere there. So this is the center of the circle which will represent that inequality. So let me draw a circle with a radius 1. So it will obviously touch both the axes because this is at 1. So let me Oh yeah, this is the circle that represents a radius of 1 which is equal to 1, and if I shade the inside of this particular circle, that becomes less than equal to 1. But they have given another condition where argument of z minus 1, so I will have to change it also, so it will become argument of z minus positive 1, right? So we will focus this z1 for us in this case, and the argument of 3, it is less than equal to 3/4 of pi. So 1 will be, positive 1 will be somewhere here, and we have to draw 3/4 of pi counterclockwise, right? We always start from this line 0, and we will draw a line which is 3/4 of pi, which is basically 3/4 means 45 degrees in this direction. Almost this. Yeah, this will be 3/4 of pi. If we start from this one, if we consider that one as 0, so this will be 3/4 of pi. And which area is common in the two? This area. This area is where the argument is less than 3/4 of pi with reference to this point, and it is less than 1 in magnitude with reference to this point. This is your final drawing. Here in question number 3, we're being asked to show, rather to explain, why this particular relationship is a linear function when we plot y against ln x, right? So to explain why, we must show that it can be converted into this format, y equal to mx plus c. That's the equation of a line. And in this case, the y should not be against x, y should be against ln x. This should be the format. So let's try to do that. So what we will do, we will convert this equation into the equation they want. So we'll put a ln in front of this and ln in front of this, and this whole thing is inside ln now. So I can write like this, and since a and 3 to the power minus y are multiplying, we can separate them according to logarithmic rules. Alright, so now this is an exponent, it can come and become a coefficient. So ln x equal to ln a minus y ln 3. And let's bring it to the left side so that I can isolate y. So, and we'll bring ln x to the right side. So y ln 3 equal minus ln x plus ln a, right? So I need to isolate this, so I'll remove ln 3 from here. So we'll divide by ln 3, divide by ln 3, and ln 3. So y is alone now, so y equal to minus 1 over ln 3 ln x plus ln a over ln 3. Some of you may try to divide this or write a negative. That is not possible. A negative of ln becomes the division of contents, but not division of lns become negative. So we will leave it like this. Alright. So what are they asking us? We have already shown it. So this becomes y equal to, this is the gradient m, so let's write here m equal to minus 1 over ln 3, and this becomes the y-intercept. Because it is in format of y equal to mx plus c, this is a line. This will form a line when we draw a graph. Now the b part, In B part, they're saying that this particular graph will intersect y-axis at 1.3. That means there is y-intercept. Find the value of A 2 decimal places. This is what they're saying. So basically y-intercept ln A over ln 3 is 1.3. So ln A becomes 1.3 ln 3 and let's make it ln A equal to ln 3 to the power 1.3 and let's convert it to A's. Separate A and get rid of lns. It becomes e to the power ln 3 to the power 1.3. Whenever we have e to the power ln, they cancel out. Answer is 3 to the power 1.3, which will be 4.172 decimal places. This is question number 4, where they are asking us to integrate this by parts. And in by parts, we have 2 parts multiplying. Here we have just 1. Yes, that is the first challenge. Second challenge is which one to take u and which one to take v, right? So, first of all, there is no second part that is multiplying, so what will we do? We will forcibly write 1 in front of this and 1 is multiplying with it. Now, which one is u, which one is v? So, we select v and u according to L-I-A-T-E. This is the sequence in which we should select u. Okay, u is the one that is going to be differentiated. See, can you see it is u here and by parts, so we need u prime later on. So the one which will be differentiated is used like this. L stands for log, I stands for inverse, algebraic, trig, and exponential. And we can see we have inverse, tan inverse here. And that should be our u. So u is tan inverse of x, right? And v will be, v prime will be 1. Okay? So basically to find v, we have to integrate 1. Yes? So which will be x. So we got v equal to x and u equal to tan inverse half x. So we have first part of the solution ready with us. So we will write it equal to u is tan inverse half x and v we just got x. Now what is challenging part is the second part, right? And for that we have to differentiate u. For this, we should know that integration of 1a square plus x square is 1 over a tan inverse x over a plus c. So that means if we differentiate this, we should get this, right? But in our question, there is no 1 over a. So what will we do? We'll write a here and we'll get rid of this, right? So it will be a over a square plus x square equal to tan inverse x over a's differentiation. And that's what we want. So differentiation of this will be, what do we have? X over 2, yeah? So it will be 2 over 2 square, 4 plus x square. That is the u prime, okay? Let me give a background of this. Why this is the answer? Okay. So what do? Let's do it here. Tan inverse that is the case. Yeah. X over 2 will be tan u. Correct? X equal to 2 tan u. Now we will differentiate this. Dx over du equal to 2 secant square u. Dx over du becomes 2 1 plus tan square. That is the identity, right? which is 2 plus 2 tan square u, right? Now we have already known that tan u is x over 2. So we can write it 2 plus 2 over 2 times x over 2 squared. Yeah? And that becomes, if I square it, 2 plus, this 2 will cancel with one of the 2's here. So it will be 2 over x square over 2. And if I simplify this, it is, mind it is dx over du, not du over dx. And u prime is du over dx. So we'll reciprocate it and we'll get this one. That is the story. But you don't need to show this in your exams. This is just for the sake of understanding. So we got u prime, we got v. So now we can write here. So it becomes 2 minus 2 over x square plus 4 and v was already given to us for x. Yeah, and we have to integrate this. So our answer should be x tan inverse half x minus, if you see 2x is differentiation of x square plus 4. Yeah, so when numerator is the differentiation of denominator, we use ln. It will be ln of the denominator, x square plus 4. That's it. And plus c. This is our integration of u v prime, which was actually 1 times tan inverse half x. But now the definite integral we have to evaluate. So we'll put 2 and 0. Let's say 2 and 0. And we'll substitute and we'll get our answers. Alright. So substituting 2 tan inverse 2 over 2 minus ln 2 square plus 4 plus c minus 2 tan inverse 0 over 2 plus, because we are subtracting, okay, ln 0 square plus 4 minus c. So plus c and minus c cancel out. This is 0, tan inverse 0 is 0. Okay, so now 2 tan inverse 1. Tan inverse 1 is pi by 4. So we write pi by 4 here. Yeah, minus ln 8. 2 square plus 4 will be ln 8. Okay, plus ln 4. Alright, they want us exact value, so we will get it. Pi over 2 and plus ln 4 over 8. Because this is positive, that is negative, so that's how they combine. And finally it will be pi over 2 plus ln half. In this question number 5, they are asking us to find square roots of this complex number. Okay, since we want to find square root, let's call those square roots a plus ib. Alright, that means 10 minus 4 square root 6i, its square root is a plus ib. So to get rid of the square root of a square root, so we will square both sides. So we can write here 10 minus 4 square root 6i equal to a square plus ib square plus 2a times ib. Yeah, we square both sides. So let's do it further. A square minus b square plus 2ab I is 10 minus 4 square root 6i. So this is the real part and this is imaginary part. Right? So this is also real part on the right side and this is imaginary part, right? That means a square minus b square equal to 10 and 2ab, let me write here, 2ab equal to 4 square root 6. So these are two simultaneous equations, we can use them. So I will do what? I will write a square equal to b square plus 10 and a becomes square root b square plus 10. That we will use here. Let's use it properly. So 2 square root b square plus 10 times b equal to 4 square root 6. Let's square both sides. It will be 4 b square plus 10 b square equal to 96. Tell the square of this. Okay, so it becomes 4b square plus 40 other b4. 40b square minus 96 equal to 0. All of them can be divided by 4, so let's divide. So it becomes simpler. So it becomes b4 plus 10 b square minus 24 equal to 0. Or so this gives us b square equal to 2. This gives us b square equal to minus 12. Since they said a and b both are real and exact, this can't be our answer. It is not real because if we square root of a negative number would be complex. So we can't use it. So this gives us b equal to plus minus square root 2. And let's find a with this particular, this one, this relationship. Equal to square root b square will be 2 plus 10 and that comes out to be square root 12. So we have plus minus square root 2 as b and plus minus square root 12 as a, but we don't know which combination of plus and minus will work. So what will we do? We'll list them. First, a square root 12 plus square root 2i, then square root 12 minus square root 2i, then minus square root 12 plus square root 2i, and minus square root 12 minus square root 2i. We can put them one by one in our calculator and square, right? And see which one gives us 10 minus 4 square root 6i, which is our question. And we'll see that this and this, they don't work, and these two are our final answer. So without square, write these as your answers.
Question number 6a asks us to prove the left hand side is equal to right hand side. So let's focus on cosecant 2 theta, which can be written as 1 over sine 2 theta. I'm focusing on left hand side. Minus cot can be written as cos 2 theta over sine 2 theta. So both of them have same denominator. We can write 1 minus cos 2 theta over sine 2 theta. Our ultimate aim is to get tan theta, that which is sine over cos. Yeah, tan theta is sine theta over cos theta. That means this sine 2 theta and cos 2 theta should be changed to some identity so that we are left with only sine and cos. So let's look at the denominator first. Sine 2 theta can be written as 2 sine theta cos theta. This identity is part of your formula sheet. Now I need the cos theta denominator, that means this sine should go. So what will I do? I will convert this into a cos 2 theta. We have three identities for cos 2 theta. First is cos square theta minus sine square theta. If I substitute cos square theta minus sine square theta, that may give me sine theta on top, because 1 minus cos square theta will be sine square theta. Okay, I can use this one straight away. No, nothing else is needed. So 1 minus cos square theta minus sine square theta. So this line is here. So we get what? 1 minus cos square theta minus sine, not minus, plus. This negative and this negative will make it plus sine square theta over 2 sine theta cos theta. Now 1 minus sine cos square theta is sine square theta. This is another identity from here. Sine square theta plus cos square theta is equal to 1. So that means we can write this cos square theta can be brought to the right side. So this is gone from here. So sine square theta is 1 minus cos square theta. So I will write sine square theta in place of this. So what do we get? Sine square theta plus sine square theta over 2 sine theta cos theta. And now what we needed was sine on top. So there becomes 2 sine square theta, right? Sine square theta plus sine square theta. Bottom we had 2 sine theta cos theta. 2 cancels with 2. One of the sine on top cancel with this sine. And finally we are left with sine theta only on top, cos theta only at bottom, which is equal to the right hand side tan theta. So we proved the identity. Okay. Hence, that means take the help of A part, show that this is half ln 2. Just see cosecant 2 theta minus cot 2 theta. Yes, exactly same. That means we can write just tan theta in place of the whole question. So this question now becomes from 1/4 of pi to 1/3 of pi and just tan theta here, d theta. We have to show it is equal to this. So we can't find the integration of tan theta straightforwardly. So what will we do? We'll do this 1 over 4 pi 1 over 3 pi, and the stage before tan theta in our previous part, look, was sine theta over cos theta. That's what we are going to substitute this with. Sine theta over cos theta d theta. Now I will use substitution for this. Why? Because sine theta is a differentiation of cos theta. So I will assume that cos theta is equal to u. So du over d theta, differentiate both sides by with respect to theta will give me minus sine theta, right? That means minus sine theta d theta cross multiplication is equal to du. Sine theta d theta, and if I put a minus here and minus outside, that means I have made no change, it is still plus. And why did I do that? Because this part is du now. So it becomes du here, and we have 1 over cos left here. So 1 over u will be here, and this negative was extra, so minus this. All right. So whenever we have a reciprocal of a linear expression, algebraic expression, the integration is ln natural log of that expression. I say linear, we have to further divide it by the differentiation of what is this, but differentiation of u will be 1, so there is no point, plus c. This is the integration of this. Now put back u equal to cos theta. So our integration which we left here will be this 1 over 4 pi to 1 over 3 pi, and now we got our integration already, rather it is already integrated, so we don't have to write the integration part now. We will write straight away the solution, minus natural log of cos theta. Yeah, u was cos theta, that's why plus c, from 1 over 4 pi to 1 over 3 pi. And now we'll substitute the values of theta as 1 over 3 and 1 over 4. First 1 over 3 minus natural log cos 1 over 3 pi plus c minus natural log cos 1 over 4 pi plus c. So this c and this c can get cancelled because there is a minus in between. So what do we get here? Minus natural log cos 1 over 3 pi is half plus natural log cos 1 over 4 pi is 1 over square root 2. Alright, let's write square root 2 over 2. Okay, so since one is subtracting from the other, we can combine these natural logs because they are both having natural log. We can combine them. So this is positive, so it will come on top. This is negative, it will become denominator 1 over 2. Both of them have same denominator, cancel. So we are left with this, but it is not matching here. So what we can do, we can write this 2 to the power 1/2, and in logs, whatever is the exponent of the content of natural log can become the coefficient, which is half ln 2, and that's what they're asking us to show.
Question number 7 says that there is a curve and its gradient at a general point xy is proportional to this. So gradient is nothing but the differentiation of curve's equation. It is proportional to y over square root x plus 1. Now we want to make it equal, so we will make it equal by replacing proportional by equal sign and writing a k in front of right side. Now we have to find the solution, the equation of the curve by solving this differential equation. So we'll combine dy with y and dx with this. So it has to be a numerator. Dy and dx have to be numerator. So it will be dy over y. Just keep k to the left side only, and k dx over square root x plus 1. And let's integrate both sides. So dy over y, integration will be ln y. K is constant, so we'll keep it outside. And integration of 1 over square root x minus x plus 1 is 2 square root x plus 1. If you do in detail, convert this to power half and you'll get this answer, plus c. This equation is okay, but we need to find the value of k and c to complete it. And for that, we will substitute the 2 points they have given us. The first point they have given is 0, 1. We substitute ln 1 equal to k 2 square root 1, so 0 plus 1 plus c. So ln 1 is 0, and the square root of 1 will be 1, so it will be 2k plus c. So we can say that c is equal to minus 2k from this particular equation. Now second point they have given is 3e, 3 comma e. So we substitute it here, ln e equal to k 2 square root t plus 1 plus c. So ln e is 1, okay, k is k, and this becomes 4. 4 square root 4 is 2 times 2 is 4k. This becomes 4k plus c. Alright, and now let's put c. Value of c is to minus 2k from here. 4k minus 2k. So 2k is 1, and that gives us k equal to, let's put c here. C is minus 2 times k, which is half now. C is minus 1. So the final equation becomes, this will be the equation that will give us ln y equal to half times 2 x plus 1 minus 1. So 2 and this cancel out, so we're left with ln y equal to square root x plus 1 minus 1. Y equal to e to the power square root x plus 1 minus 1.
Question number 8 says the equation of a curve is this. For negative half pi till positive half pi, find the x coordinate of the stationary points. We'll get more than 1 point of the curve. Give your answer correct to 3 decimal places, 3 dps, okay, when appropriate. Okay, so for stationary point, dy over dx is always equal to 0. That means we have to differentiate this particular part where y is e to the power minus 5x tan square x, right? So we have to differentiate this by finding dy over dx. There are two parts which have variables and they are multiplying. That means we will use product rule in this case. So e to the power 5 minus 5x is differentiated, but nothing happens to tan square x. I'm doing product rule, okay? So, and second one, e to the power minus 5x is unchanged, but tan square x is differentiated. So differentiation of e to the power minus 5x will be minus 5 e to the power minus 5x. Tan square remains tan square x plus e to the power minus 5x remains unchanged, but when we differentiate this 2 will come in front and the exponent of tan will go down by 1, which is 2 minus 1, 1, no need to write 1. Further, we will differentiate the base was tan x. So the differentiation of tan x is secant square x. Okay, now we can see that e to the power minus 5x is common in both of them, so let's take that common. What is left inside? Let's write this plus first because this is minus, so I will write this term first where e to the power minus 5x is already taken common, so we are left with 2. Tan x and secant square x, they are not okay. We can change this one later, right? Okay, so what will I do? I will write 2 tan x, but in place of secant square x I will write 1 plus tan square x. That's the identity. Secant square theta is 1 plus tan square theta. This is an identity given to you in your formula sheet. Okay, all of them are written here. Now we'll go to this one. Negative 5 e to the power minus 5x is taken common, tan square x. Okay, now we can see that when we open this, let's open first and then talk about it. 2 tan x, then plus tan cube x, and that will be 2 again. 2 tan cube x minus 5 tan square x. Okay, this all thing has to be equal to 0 because we said dx have to be 0. I will make it equal to 0. So all of them have tan. Can you see? I will take tan out. So e to the power minus 5x tan x. What is left here? 2 and plus 2 tan square x minus 5 tan x equal to 0. Let's focus on this one now. Isn't this a quadratic expression now? Let me assume that tan x is let's take an alphabet u. Okay, so let's see what it happens, and I will factor it to get a next step here. So this equation becomes 2u square minus 5u plus 2 equal to 0, because they are equal to 0. So either e to power minus 5x equal to 0, 10x equal to 0, or we'll get something from here. It will be, if I factor this, 2 square minus 4u minus u plus 2 equal to 0. 2u common in this one, so u minus 2 minus 1, u minus 2 equal to 0, 2u minus 1, u minus 2 equal to 0. So u was 10x. That's what I will write here. This will give us these two, 2u minus 1, 2 tan x minus 1 equal to 0, and the fourth part from this is u minus 2, 10x minus 2 equal to 0. This whole question is worth 8 marks. That means we have to do it, solve each part separately. Let's talk about this one first. E is a constant. It is between 2.5 and 3. There's a fixed value for this. No matter what exponent we give it to it, it will never be equal to 0. That means this particular option is rejected. There is no solution from this. Tan x is 0. That means x is tan inverse 0. And they have given us the domain negative 1/2 pi to full pi. So that means which one they're saying? They're talking about this and this quadrants. Whenever we have 0, just put tan inverse 0 in your calculator and you will get x equal to 0 for sure, because this is the place where tan is 0 when angle is 0. So this gives us x equal to 0. Let's talk about this one. 2 tan x equal to 1. That means tan x equal to 1/2, and x will be tan inverse 1/2. Yeah. So the tan inverse 1/2, if we use our calculator, it comes out to be 0.4. Let me 0.463647 also. So they said we have to round off to 3 decimal places. So it will be 0.463. Let's look at this one. Tan x is equal to 2, x equal to tan inverse 2. So let's put tan inverse 2 in the calculator. Again, both the answers will be in this one, this quadrant only, because here in this quadrant tan is negative, so no answer in this quadrant. So tan inverse 2, 1.1071. It gives us 1.107148, but they said 3 decimal places, so we will leave our answer here. So we got these 3 answers: x equal to 0, 0.463 and 1.107.
This is the A part of question number 9, where we have to express this particular function in partial fractions. Alright, So first of all, we'll look at a degree of the numerator, which is 2, because 2 is the highest degree. And the degree of the denominator is 3. So we can't divide. We have to straight away go to partial fractions. So what will we do? We will express this like this. 14 minus 3x plus 2x squared over 2 plus x. 3 plus x squared equal to a over first factor, which is 2 plus x, then bx plus c over 3 plus x squared. Why bx over plus c? Because it is degree 2 x squared, so we have to write bx plus c on top. So if we ignore the denominators now, so only the numerators will be 14 minus 3x plus 2x squared, and these two will multiply, so this 3 plus x squared will multiply with a, and bx plus c will multiply with 2 plus x. Denominator will be exactly same, so we are ignoring both sides. By what? Let's assume x is equal to minus 2. So we'll substitute minus 2 in the whole of it. Purpose is that this part gets cancelled out. So 14 minus 3 times minus 2 plus 2 times minus 2 squared equal to a 3 plus minus 2 squared and plus 0. Why? Because 2 minus 2 will be 0 and this whole thing will become 0. Alright. So it becomes 14 plus 6 and that will be 4 times 2, 8 equal to, this will be 4 plus 3 is 7. Yeah. Now 14 plus 6 is 20 and 28 equal to 7, 8. And 8 comes to 28 over 7, which is 4. We got our 8. Let's try to find something else by comparing just the constants. So 14 is the constant on this side. And what constant will you get here? 3a, yes? Because 3x squared cannot give you a constant. Yeah? So 3a is the only one. And here, in this one, c and 2, when they multiply, they will give us a constant. Others will give us x's, which we are not interested in. So 14 equal to 3 and a is known to us now, 4 plus 2c. 14 and this is 12, which comes to the left side, becomes 2c. 2 equal to 2c and c becomes 2 over 2, which is 1. So we got a, we got c, b is the only one left. So what we can do, we can compare the squares now. Okay, x squared. So 2x squared, right? 2x squared is on the left side, which has exponent 2. Let's see here. We will get ax squared on the right side. Alright, then we'll get bx multiplied by x, will be bx squared. And we will get nothing else. Wow, that's nothing else. So x squared and x squared get cancelled out. So 2 equal to a is 4 plus b, and b becomes 2 minus 4, which is minus 2. So we got a, b and c, all three. So now we can write our final expression with this. So a is 4 over 2 plus x plus b is minus 2. So let's write it later. C is positive 1. So 1 minus 2x over 3 plus x squared, and that is our x. This is part B, where they are asking us to expand. The answer we got in part A, because they have used the word hence, means we have to expand this up to x squared. So we can rewrite what we got as 4 2 plus x to the power minus 1 plus 1 minus 2x and 3 plus x squared to the power minus 1. And to expand them, we will use this formula. A plus x to the power n equal to a to the power n 1 plus n x over a plus n minus 1 over 2 factorial x over a squared. Because we have to go to up to square only, so I will write this one. Alright, so let's do them separate. I'll expand this one first. So let's keep 4 here outside and use this formula to expand this. Okay, so 2 to the power n 1 plus minus 1 x over 2. Yeah, x over 2 plus n minus 1 means minus 1 minus 1 minus 2 over 2 factorial x over 2 square. Okay, so 4 remains 4 and 2 to the power n. I didn't write n minus 1. So 2 to the power minus 1. Rather, this and this can cancel out, right? It is 2 to the power minus 1 is half. So 2, and it is multiplying with whole of it. So we can cancel them out. So let me redo this. So this was minus 1, and this got cancelled out. So 2, 1 minus x over 2, and this plus 2, this is also plus 2, they are also gone, plus x square over 4. This is the expansion of the first part. Let's expand the second part, which is 1 minus 2x a to the power n, which is 3 to the power minus 1 in this case, multiplied by 1 plus n. X in this case is x square. We will stop here. Why? Because next one will be x to the power 4, and we have to stop at x squared. So let's expand this one also. 1 minus 2x, and then it is 1 over 3, and 1 minus x squared over 3. Now 1 multiplied, okay, 1/3 will keep aside. 1 multiplied by 1 will be 1. Okay, 1 multiplied by minus x squared over 3. Then minus 2x times 1 will be minus 2x. And then it will be 2x cube over something, so we'll not write that one. The final one we are not writing because it's x cube, which is crossing x squared. Alright, so that becomes 1/3 minus x squared over 9 minus 2x over. So now we can, because there's a plus in between, right? Yeah, there is a plus in between. So we can add the two parts now we've got. So expand this. 2 minus 2x over 2 will be just minus x, and 2x squared over 4 will be x squared over 2. And then we have 1/3 minus x squared over 9 minus 2x over 2. And we will simplify this now. 2 plus 1/3 will be 7 over 3. Minus x and minus 2x over 3 will be minus 3 minus 5 over 3x. And x squared over 2 and x squared over 9 will be 9x squared minus 2x squared, 7 x squared over 18. Question 10 part A has this picture, and it clearly shows that there are two sectors with radius r, and M is the midpoint of A, B, and angles A and B both are x radius. That means these two sectors are exactly same. Also, ABCD is a trapezium, and they have confirmed it here. It's a trapezium. You can see it's a regular trapezium. So 90% of the area of this trapezium is made up by the sectors, two sectors. So the area of sectors will be, each sector will be angle times radius square divided by 2, correct? Since there are two sectors, we'll multiply it by 2. It is 90% of the area of the trapezium. Area of the trapezium is 1 over 2 first parallel line, let's say the longer one, the AB, which is equal to 2R. For the shorter line, which is DC, we will convert it to in terms of R later on. Okay, and multiply by height. And let's say height is, this is height. Okay, so let's call it H. This is what our situation is, and we have to show this equation. Alright, so our challenge is to convert DC and H in terms of R. So let's start with H. Let me construct a height here. This one. Yeah? This will be the height of the trapezium. And that will be what? If this is R, hypotenuse, and this is H. Yes? So H over R, let me do it here. H over R equal to sine theta, sine x, isn't it? So H becomes R sine x. So we got H in terms of R and x. So in place of H, we will write R sine x. Done. Now for DC, let's take this length, the base of the same triangle. So let's call it y. Okay, this length as y. So that y over r is cos x. Y is adjacent, r is hypotenuse. So y becomes r cos x. That means if I make a height here, this will also be the same length as this, r cos x. So DC, can we write DC is equal to 2r, the whole length of AB minus this length and this length. If we subtract these two lengths from full length AB, we'll be left with this length, which is equal to DC. Yeah? So 2r minus, and we got this as that length, 2 times r cos x. Why 2? Because there are two lengths. Alright? So let's take 2, okay, let's not take anything else. So let's substitute everything here now. This 2 and this 2 will get cancelled out. So we'll be left with x r squared. 90 over 100 will be 0.9. Okay. Half 2r plus, now DC is 2r again minus 2r cos x. Back to close. H is already written. Done. So let's take something out of these, because this is 2r plus 2r, 4r. Yeah. So we'll take this out. So x r square equal to 0.9 half. I'm taking 2r common out of them, right? So 2r taken common. Out of 4r will be left with just 2. Out of 2r cos x will be left with just cos x. And it is coming close to what we want. Alright. So this 2 and this 2 get cancelled out. Alright. So we will be x r square on this side, 0.9 on this side. Now this r and this r will give us r square. And 2 minus cos x sin x. Anything else? Not really. So r square and r square get cancelled out. We are left with x equal to 0.9 2 minus cos x sin x, and voila, it is what they wanted. B part I needed some space, literally, so I have cleaned everything. It says that verify by calculations that x lies between 0.5 and 0.7. And to do that, there are mainly two methods, but I like this one. So our equation was x equal to 0.9 2 minus cos x sin x, right? So do what? Bring everything to the left side. Always do this. So it will become x minus 0.9 2 minus cos x sin x. And now we'll be left with something here. That can be anything, right? In this equation it is 0, but I'm not bothered about what is on the left side, right? Since they have given us two numbers, we'll just plug in those two numbers in this part, all right? So first let's substitute 0.5, it will be 0.9, 2 minus cos 0.5. Since angle is so small, obviously it is radians. And they have also mentioned here that x is in radians, so never use degrees in this one. 0.5. Okay, and see what number you get, and you are interested in sign of the number, you're not interested in the value of the number. And if I use my calculator, I get plus 0.1569. What was 0.7? 0.7 minus 0.9, 2 minus cos 0.7 sine 0.7. Put this in a calculator and you get minus 0.1614. So can you see, one is negative, one is positive. So that means they cross the root which was 0 originally, right? One is more than it, one is less than it. That means our solution lies between 0.5 and 0.7. Part C. They are saying that we have to show that the sequence we got, the equation we got in part A, which was this, converges according to this iterative formula. In other words, they are asking us to convert this equation into this format of iterative formula. So we can see that there is cos inverse here. Yeah, that means we have to isolate x of this particular cos. We have to isolate this, and let's do it. So let's get rid of 0.9 and sin x first by dividing by 0.9 sin x both sides. So x divided by 0.9 sin x both sides. So 0.9 and 0.9 cancel. Sin x and sin x cancel. So we are left with what? X over 0.9 sin x equal to 2 minus cos x. Now I need to isolate this. Let's bring this to the left side and let's bring this to the right side. Okay, and let me do it here. So cos x will become positive on the left side, equal to 2 minus x over 0.9 sin x. Yeah, and if we find the inverse of cos now, x will be cos inverse of 2 minus x over 0.9 sin x. And can you see, it is exactly the same. This becomes n plus 1, this becomes n, this becomes the rule of iterative formula. Left side becomes n plus 1 and the x on the right side becomes just n. Finally, usually the D part says that find the value of x by using the iterative formula, and iterative formula was the one I've written in front of you. So x2 will be cos inverse 2 minus, now xn, we should start with the number which is between 0.5 and 0.7. That was what we needed, right? So it is 0.6, which is exactly in the middle. So let's start with 0.6. So 0.6 over 0.9 sine 0.6. This will be our x2, and 0.6 is x1. Right? That's what we started, and we'll keep on repeating this unless we get it. I'll fast forward this process and finish with the correct answer. So we can see that x3, if I round off to 2 decimal places, which they are saying we should have, so it comes out to be 0.62. And 617 also rounds off to 0.62. Since we are stabilizing around 0.62, 0.62 is the solution of this particular iterative formula. In question number 11, they have given two position vectors OA and OB, and they are asking us to show that OA is equal to OB. If you notice, there is no vector sign on top. That means they are asking about the magnitude only, OB, line segment OB and line segment OA. Right? So we have to find the magnitude of OA, which is square root 2 square plus minus 1 square, right? This one. So it comes out to be 4 plus 1, which is square root 5. Similarly, OB will be square root 1 square plus minus 2 square, and obviously this also comes out to be square root 5. They are equal. So now they're saying use scalar product to find the angle AOB. So AOB, angle AOB will be cos inverse OA dot OB, the scalar product, divided by the magnitude of OA and magnitude of OB. So we already know these two, OA dot OB we have to find out. So let's find 2I minus J dot J minus 2K. Alright. Let's first put the unknown things. 2I minus J plus 0K. There is no K in the first one. Dot 0I plus J minus 2K. So now they have 3 each, and now we know that A dot B is 2 times 0, which is 0, plus minus 1 times plus 1, which is minus 1, plus 0 times 2, which is 0, answer is minus 1. So now substitute everything in this formula here, and we'll get it. So that is minus 1 over square root 5 cos inverse, which will be cos inverse minus 1. Now obviously it will be an obtuse angle because it is negative. Cos is negative in second quadrant. Let's find. It is 101.53 degrees. In B part, they are saying that M is midpoint of AB. So we will have to draw in such a case because we don't know how it looks like. So let's say AB is this. So what were the coordinates of the head of A? It was 2, minus 1, 0. Because position vector, whatever is the head of the position vector is the coordinate of the head. And this is 0 plus 1, rather, minus 2. So the midpoint is, this is B, M, will be somewhere here. And what are the coordinates of this? Midpoint 2 plus 0 divided by 2, which is 1. Minus 1 plus 1 divided by 2 will be 0. 0 plus minus 2 divided by 2 will be minus 1. This is the coordinates of M and also the position vector of OM. Let's say O is here. Since OA and OB were equal, so it's an isosceles triangle they are forming. We know this is 0 square root 5. Square root 5. So if we draw a line here, this will be a perpendicular line. Yeah, isosceles triangle. Alright. So they're saying that there is a point on OMP such that this PA length is square root 7 times OA. That's the ratio. OA is this square root. No, that is not possible because square root 35 will be much longer than OA. That means this is the wrong positioning of P. So that means P has to be somewhere here. So that it is square root 7 times square root 5, which becomes square root 35. And they are saying possible position vectors of P. That is, P has more than one possibilities. Of course, we can see that it can be here also. Right? And now we have to find the position vectors with reference to O. What are the coordinates of these points? That's what they're asking in a sense. All right. So let's write the equation of the line OM first. OM. equation of the line OM, because it's lying on OM. And for an equation of a line, we need a point which is, let's say, 0, 0, 0. I'll take this, the easiest one, and then let K some parameter, and the vector is 1, 0. What is OM? Vector OM is 1, 0, minus 1. 1, 0, minus 1. And let's convert it to parametric form also. That will make it easy. 0, 0, no need to, just look at this. This will be K, this will be 0, and Z will be minus K. Yes? And whatever is the vector, say OP1, let's call it OP1 or OP2, the magnitude of OP, I'm not writing 1 or 2, both directions, will be square root K square, the x component, K square plus 0 square plus minus K square, which is 2K square square root, or the square root 2K. This is the magnitude of the points P1 and P2 from O. Yeah? So now the values of K are to be found out, and we can find that by Pythagorean theorem, because we know the length of AM. Let's find AM also. Magnitude will be square root 2 minus 1 square. That's the distance formula I'm using basically. Basically magnitude is also found this way. Minus 1 minus 0 square plus 0 minus minus 1 square. Okay. That comes out with 2 minus 1 square will be 1 square plus 1 square plus 1 square. Okay, basically square root 3. So this length is square root 3, this length is square root 35, and we can find this length as well. OM, we could have found the magnitude of the vector also. So let's find OM. OM will be square root 1 square plus 0 square plus minus 1 square, which is square root 2. So this length is square root 2. Alright, now MP. Any MP, okay, it can be MP1 or MP2. It does not matter. Both of them will have same magnitude. And that we have to use Pythagorean theorem now. Square root, this is 35 square minus this square root 3 square. So basically it is square root 32. Yeah, and that will be 4 square root 2. So this was a general MP, but we will separate them now. MP1 equal to MP2 equal to 4 square root 2. Both of them are 4 square root 2. But we want with reference to this length we found earlier. This one was with reference to O, right? Because our point was 0, 0, 0. That's what we take, and we want with reference to O. Alright, so now we want to find OP1. OP1 equal to this 4 square root 2 is the whole thing. I've already done that here. 3 square root 2 will be the remaining distance. If the whole length is 4 square root 2 and OM is square root 2, the remaining will be 3 square root 2. So OP1 will be 3 square root 2. Similarly, we know this distance from here till P2, MP2 is 4 square root 2, right? But from O, because we are interested in position vectors. From O, OP2 will be 4 square root 2, which is this distance, plus square root 2, because that's how we have to find distance from O, which is 5 square root 2. So now we have got two lengths of P1 and P2 with reference to O, and we will compare them with the length we got here in the previous part as a general length. So for OP1 first, let's say P1. Okay, the length was 3 square root 2 and it will be equal to square root 2k. So square root 2 and square root 2 cancel, k becomes 3. Similarly, for P2, 5 square root 2 equal to square root 2k and it will give me k equal to 5. But if I use 3 and 5, both will be on the same side of O. It is so because we ignored the plus minus. When we square rooted this one here, it would have been plus minus square root 2k. And when we square rooted 32 here, it should have been plus minus square root 4 square root 2. Since this m is on this side and the P2 is on the same side, we will take this 5 as positive 5 because it is going in the same positive direction as m is going. It is multiple of m in that direction. But 3 is in opposite direction of m. That's why we should take it as minus 3. What we did not do here, we have to correct it here. So the first vector OP1 will be minus 3 times, k is minus 3 for it, 1, 0, minus 1, that gives us minus 3, 0, 3. Yeah, basically I inputted it here in this XYZ parametric form, or you can write minus 3i plus 3k. And if you use the same plus 5 for OP2, it will give you 5, 0, minus 5 or 5i minus 5k. These are the two answers, two possible quotient vectors of P.